Okay, so let's just go over the diagram in general. Look at the different components. We have our ignition switch over on the left-hand side. And then you see where it says P lead and you have a little line coming down. Draw an arrow at the end of it. That's all that means. It's not a wire. I feel like that could be a little bit deceiving. All right, what is this component in the red square? Capacitor, good. Whoops, then we have the contact points. Then the cam. Now which side of the transformer would this be?
Primary.
The primary. Does that make sense so far? Is this a step up or step down transformer? Step up.
Where the current Y is.
The current does step down. Very good, Sonny. Okay, then we have the secondary coil on the right-hand side. And of course the rotor in the middle, which turns then the distributor block, and of course the spark plug. So the first thing that happens, like you said, this is in which position is the rotor in? Full register. Very good. We're going to consider for the moment that the points are actually closed, so I'm just going to draw them closed. Don't think about that. We have to start with the points closed in order to illustrate what we're talking about. So we're going to start there. So initially we have flux going from north to south. Does that make sense? So far so good? And that is the flux. That creates current in the primary. So the green in this case is current. The orange is flux, green is current. I want you to remember to keep those two things separate in your mind. Okay? They definitely go back and forth and cause each other, but they are separate. So if we have the magnetic flux going from north to south, that's going to create a current going a certain direction. That current in the primary creates another magnetic field. So now we have two magnetic fields. The flux from the magnetic circuit and the flux from the secondary circuit. Sorry, flux from the magnetic circuit and flux in the primary coil. Any questions so far? All right.
One question.
No, go ahead.
In the schematic, you showed a lab. The circuit was connected. Was that different?
The circuit was connected.
Two circuits. The primary, the secondary wirings.
Okay, that was in the battery ignition system. Get totally, yep, good question. Get that completely out of your mind. Yep. Put that in the battery ignition box. Yep, for a magneto, the primary and the secondary circuits are completely separated. That's a good question. Okay, as you know, the rotor will turn. Now, if the point's open, that would change what we're looking at right here. So we're just going to take the points out of the system for a little bit. So we're going to look at what would happen if the point stayed closed. So the rotor turns. What position is this? Neutral. Very good. Turns a little more. And then it comes to full register the opposite direction. Which way will the lines of flux go at this time? Counterclockwise. Good. North to south again. And so will the current stay the same direction or flip? That means the current in that primary circuit is going to go the other direction. So if the point's never opened, all you would have is an AC current back and forth in the primary. And when you see those two grounds on the bottom, they're basically connected, right? Grounds are common. So you would just have AC back and forth in the primary. Questions?
Wait, where are the points?
They're closed still. We're saying if the point stayed closed the whole time, this is what you would see.
Oh.
Questions? Yes, sir.
So the magnetic field elapses pretty quickly.
We'll talk about that in a second. Hang with me and then see if we answer your question. Yep. If the points never open, the magnetic flux doesn't collapse very quickly. It's just changing. It's going like this. It does. I mean, it grows, it expands and contracts because it builds the opposite direction. But nothing drastic. So we again have the flux in the primary. Because we have current in the primary, that's going to create flux in the primary. And that's also going the opposite direction.
So the expansion and contraction of the field is
Yes.
due to the magnet spinning.
As the magnet spins, the flux goes one way and then the other. That makes the current to go one way and then the other. That current in the primary causes that primary flux to build and collapse one way and then the other. So it is because of the rotor turning that we're getting an AC output at this point. We have two magnetic fluxes that we're dealing with. One in the core, in the square, and then one in that coil. And they actually add together. Okay? And so that is why, let me see.
Because really those two aren't separate, they're stacked on top of each other, so they're the same flux that's going through because of the coil is also the same flux that's just being generated through. Okay.
Yeah. The points don't stay closed. So every half rotation, the points also open. But they don't open right at neutral. It went to sleep. They don't open right at neutral because we have the coil. And remember what an inductor does? What does an inductor do? It opposes a change in current. So that means that we want to open the points a little bit after neutral to get the maximum change. So we're going to open the points at what we call E gap. And that is about 10 degrees after neutral. Let's look at what happens. So if our points are still closed and they're about to open, we obviously have flux in the core. This creates a current in the primary, which creates a secondary flux. Okay. It doesn't really matter at this point. Okay, do you see the points just open? Okay, the points open, which stops the current going through that circuit. So the current stops. And then obviously once the current stops, that magnetic flux collapses. Okay, flux collapses. So we can take all that flux away. Okay? And by that time, another benefit of waiting till E gap, by the time that happens, the rotor is already almost lined up the other direction. So not only does the flux collapse, but it instantly starts building the opposite way. And that's a good thing because it's just going to give us a maximum collapse. And that's where we're going to get the most energy, is where we had the most flux change. Okay, when that happens, that was my animation of the flux cutting across the secondary. And we get current. Whoa, 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 whoa. Okay, let me slow that down. There we go. So we get current going through the distributor to the spark plug. And then like we said, the grounds are connected. So it makes a complete circuit. And that's how you get spark from a magneto.
So, because there's flux going through, it would also create a current in that coil if it wasn't for the fact that it's not closed.
Exactly. Yeah, we need that drastic collapse of the flux to create a high enough voltage to jump 2 gaps, one in the distributor and one in the spark plug. Yep, that's why it doesn't arc every time, or it wouldn't arc if the points didn't open. If the points stayed closed, it wouldn't arc across the spark plug.
Flux being created by the magnet rotating is not nearly enough. To
Right. Yep.
So there's
still gaps, just like it was in the last one.
Is all of the energy
Okay, go ahead,
Is all
Colin.
of the energy lost in the spark, or is there a lot returning through the ground?
Well, yeah, the energy is basically, I mean, it has to jump across there, so it's a voltage loss, I guess, but the current still has to the electrons have to get back.